Okay, so next we are going to talk about the machine level structure of x86 instructions. So if you're following along in the book, please open it to page 377. You'll see a little diagram in here. This shows you what an instruction consists of. So instructions can be only 1 byte, which is very small, and 1 byte instructions are kind of like the OG x86 instructions because they're very small. You also have multi-byte instructions, like in x86 64 you can get up to 15 bytes in instruction length. Instructions can begin at any memory address. And so I want to show you here just kind of a general overview of the parts of the instruction. So let me bring out my text here. Actually, you know what? First, I think I'll just draw a line like that. Not a very straight line, but a line nonetheless. So first we have the prefix of the instruction. So the prefix is the first 0 to 4 bytes. The prefix is optional. The prefix kind of just changes the behavior of an instruction. Like if you want an instruction to loop a bunch of times, you could give it a prefix that tells it to do that. Or if you want it to access a different memory segment, you can do that as well. So that just kind of tells it a little bit of extra information. And then you have the opcode. So the opcode is the mandatory part of the instruction. You can't not have an opcode. If you don't have an opcode, you don't even really know what the instruction is or what it does. So the opcode is mandatory. And then you have something weird out here called the mod reg rm. So this is a very strange and hard to pronounce thing. This is 0 to 1 byte, very small. So basically what that does, I won't go into too much detail, but it's kind of like asking the question, who are we talking to? Are we talking to a register or are we talking to memory? Meaning, are we talking to, do we want this instruction to do something with the registers that are actually on the CPU, or do we want it to do something in memory, in the main memory, which is that cool looking thing that you plug into your motherboard? So what are we looking at? So that's pretty much what it's asking. After that, we have something called a SIB byte. Let me write that down. That's 0 to 1 byte. It stands for scale index base. So a SIB byte is basically asking, okay, so if we are using memory, so if this is telling us that we're using memory, where do we look in memory? So that kind of just like tells you where to, calculates where to look. It does that in a weird way, but we won't go into that for now. And then you have, I'm gonna run out of room here in a minute, but then you have a displacement. I'm just gonna say dis because it's easier. So you can have between 0 to 1 to 2 to 4 bytes. So the displacement byte is kind of like, it'll like move the instruction to a different place. So like, for example, if you have, like, let's say you're starting at like racks or something. So the addition register racks. You could say, okay, start at racks and then move 4 bytes forward from racks. So that's what that would do. It kind of becomes more obvious to you when you're disassembling programs, because you'll see like instructions and then you'll see right next to it, it'll have like a little +8 or like a +4 or something like that. So that's telling you that it's moving, it's being displaced somewhere else. And then after that, you have the immediate. So that immediate is 0 to 4 bytes. So the immediate is basically just a hard-coded number. The instruction carries it kind of like a sticky note. Again, I won't go into too much detail about that for now. But so these sections here, everything from the mod reg rm all the way to the end of the immediate, all of those values there, these are all operands. So operands. So operands are actually the data that the instruction is operating on, which is also technically part of the instruction at the same time. So we have a couple types of operands. We have two types of operands. So let's go back into our program again so we can talk about the two types of operands. So we have explicit operands where you've got, so like here, for example, it says sub RSP16. So see how you have two values here? So this is an explicit operand because it has two values. So you know what the destination is and you know what value you want to put in that destination. Whereas you also have implicit operands, which means the information, it's kind of implied. So if you have something here like this that says push RBP, this is an implicit operand because the compiler and the assembler, it actually knows already what value to put in there or what to do with that. So it doesn't need to know both of the values. It can only know one value. So they don't actually have to be encoded in the instruction. It's within the opcode. So I think the book has a good example, so I'll just read that. It says, for example, the destination operand of opcode OX05, an add instruction, so that'd be OX05, is always racks. And only the source operand is variable and needs to be explicitly encoded. So the destination is always racks. So anytime you use opcode OX05, it doesn't matter what value you have in there, it's always going to go into racks. So you can just, you don't have to write it with both of those values. So next time we are going to talk about registers and what all of the general purpose registers are. So these cool things that start with R, like RBP, RSP, all that. I began this tutorial kind of assuming that you already know what a register is, but you may not have all of them memorized. So in the next section, we are going to go over that. So that will be fun and interesting and hopefully open your mind more to the wonderful world of binary analysis.